Hi, I'm Hedge P, and welcome to the Robo Rodents production channel. Today we're going to look at a LEGO 4-bar mechanism. This mechanism is being utilized to lift objects to about a height of 5 inches off the ground. While this is only LEGO, it is pretty impressive being able to lift a bit more than half a kilogram of material. A 4-bar mechanism is basically a complicated lever. 4-bar mechanisms can be oriented in different ways. However, for this example, we will be setting the links parallel to each other, like the example in the top right corner. This is my friend, Prickles. As you can see, he never misses second helpings. He weighs in at about 128 grams. Fortunately for us, the mechanism can lift him without any difficulty. Other than him, we can use Duplo blocks as our weights. We will be ranging from 56 grams to 556 grams. And just in case you're wondering, a single 2x4 Duplo block is 12 grams. The more you know. Now, I'm going to play each of the experiments 2 at a time. Try and see if you notice any differences. I'll explain the science behind this mechanism in a little bit. Did you catch it? The more mass it had to lift, the harder the strain was on the motor. I tried to do this with a less powerful motor, but it couldn't even lift the arm by itself. This job requires some heavy-duty power. Along with the motor, I selected the best gear train to supply enough torque to the mechanism. In order to gain more torque, you need a ratio of more than the value 1. In this instance, the driving gear is an 8-tooth gear and therefore goes on the bottom of the ratio. The driven gear is a 40-tooth gear and goes on the top of the ratio. So it ends up being 40/8. Because the ratio is more than the number 1, the speed has also decreased. Speed and torque are proportional to each other. So when there's more torque or power, there will always be less speed. In addition to this, the ratio has also been repeated in the gear train. The driver 8-tooth gear drives a 40-tooth gear, which drives another 8-tooth gear, which drives another 40-tooth gear, and so on. In the end, this actually gives us a ratio of 125/1. What this means is that for every 125 rotations the driver gear rotates, the driven gear has only made 1 whole rotation. That's a lot of power. However, it is not just the gears and the motor that make a difference. The structure of the 4-bar also matters. But since we used a parallel structure today, we will cover this in another video. In addition to all of this, there is one more thing we can take from this experiment. Did you see the weight added to the back of the mechanism? This is used to decrease the load on the other side. The weight does not mess with the rest of the mechanism, as I put stands on the back of it. But it did do a lot to try and balance the weight on both sides of the lever. When the weight pushes down on the desk, it pushes up from the other side to help lift the load. How convenient! In conclusion, 4-bar mechanisms are simple, but effective. They affect our lives in ways you wouldn't even know. From behind the scenes, this innovation works the hardest for this generation. Be on the lookout for this mechanism, whether in toys, machines, or products you might pass every day. Well, this has been an interesting experiment. This is Hedge P signing off. I'll see y'all in the next video.